Okay, so now we've introduced this idea of power series just briefly. And again, we're going to talk about that more later. Now we're going to stop and focus on these things called Taylor and Maclaurin polynomials. So let's assume we have a function that's differentiable up to some degree, right? We can compute the derivative n times, right? And it has an answer. Okay. So what we want to talk about now is approximating the polynomial or approximating the function. And so we've already learned previously one way to approximate a function, and that was by finding its tangent line. So that was known as a linear approximation. So let's just recap how that looks, and then we're going to look at how we can extend that idea to have a second degree approximation, approximate our function with a second degree polynomial, and then later a third degree, and so on and so on. So we first want to talk about this idea of the linear approximation of f of x. And when we approximate, we have to have an x value that we approximate kind of using as our starting point. So we're going to say approximate around the value x equals a. So the picture we would have is this. If we had some graph, at some point a, and we have some graph that's coming up maybe kind of like that, some function f of x, then we can approximate that graph by looking at the point there and saying, hey, what's the tangent line? Right? What's the tangent line to the graph at that point? Right? We would extend that in both directions. And so that tangent line, notice that as long as you're really, really close to the point, the tangent line's really, really close to the function. Now, the further away from the point you get, the further the tangent line gets from the function. But at least really close, it's a decent approximation. So we approximate the function with its tangent line. What can we say about that tangent line? Well, we know a few things about it. Tangent line has the point. Tangent line has the point a, f of a on the line. That line also has a slope. Slope of that line is just the derivative evaluated at a. So using that information, if we went back to the point slope formula, which actually is the better version of the equation of a line here for this problem, remember that the point slope formula says the equation of the line is y minus y1 equals m times x minus x1. So if we put that information in, we would get y minus f of a equals m, which is f prime of a, times x minus a. And we can actually rearrange it. And instead of writing I, we would say our linear approximation, or a polynomial of degree 1, would be f of a, bring it over to the other side, plus f prime of a times x minus a. Now, f of a is a number, and f prime of a is a number, and a is a number. So we're approximating this thing using that straight line. So just y, I'm solving for y. That's my polynomial approximation of degree 1. Polynomial approximation of degree 1. And a quick little observation with this setup is to notice that a couple of things are true here. Note that P1 of A is exactly what f of a is. All right, this approximation, they agree at the point A. They're going to be exactly the same. Because if you put a in here, x minus a minus a would be 0, that whole piece would go away. P of a would be equal to f of a. And the second thing I want you to notice, that if you took the derivative of this thing, is that p sub 1 prime of a also agrees with f prime of a. And that's because f of a is a constant, so its derivative will be 0. Derivative of x minus a is 1, so you'd have p prime of a is equal to f prime of a. So at those two places, at x equals a, they agree. They agree. Okay? So that is called the first degree approximation, or the linear approximation to the function. Linear approximation to the function. And what we're going to do now is we're going to actually go further and say, okay, what if we push it to a higher degree? What would a second degree approximation look like? What would a second degree approximation look like? And as we do these, we're going to start to have a little bit of a pattern. Okay, that'll be coming in some upcoming videos.